Welcome to the Developer Servers YouTube channel. In today's episode, we're going to be synchronizing files between two directories with using Python. And there's two versions of this script. There is one version that we call the basic version that allows to copy files. And there's an expanded version that also allows for doing a dry run. You can get the source code for both versions and the link on the blog post. I'll leave a link for that and the link for the blog post in the video description. And in this video, I'm going to show you the code and talk through the code for the basic version. So let's see how we can build this file synchronization using Python. As you can see, I'm in my PyCharm project, and there is three files that are essential for this project. We have the requirement files, which we're all going to be using the tqdm for the progress part. Everything else is standard Python libraries. We have the file sync, which is the basic version that I talked before, and that we are going to, the code that we are going to walk through in this video. And there's the extended version, which you can get the source code, like I mentioned, from the link in the description. So let's see how we can build the file sync itself. So all the code is contained in the file sync.py. We start with our imports. Of course, we are going to be importing OS for the utilities, the show utility, I'll compare argument passer because we are going to, it's a command line application, so I'm going to be needing to pass the command line parameters and the tqdm for the progress part. So the first of the helper functions that we're going to need is a function to check both the source and the destination directories. So it's going to be a check directories function. It receives the source directory and the destination directory. It first checks if the source directory exists. So we are using the OS path exists with the source directory. If it does not exist, then we print a message stating it does not exist and we return false, meaning we cannot continue executing the script. If the destination directory does not exist, we can actually create it, or we should create it, because that's one of the things of the file copy. If the destination does not exist, then it should be created. So we can create it with the OX mkdirs that will create all the directory structure for the destination directory. And of course, print a message stating that and we return true, meaning you can continue executing the script. Up next, we have the function that actually does the file synchronization, or the synchronization between the directories. So it receives the source directory, the destination directory, and whether or not we want to delete the extra files that are present in the destination directory. Sometimes it might happen that in the source directory you delete files, and then you either want to fully replicate that to the destination directory by also deleting those files, or you want to keep them as a possibly a backup copy. So this flag controls that. The default is that we do not delete, so that we keep any extra files that are in the destination directory. So we first start by getting a list of all the files and directories in the source directory, of course. We're going to store that in the files to sync list. We're going to be using the OS walk, and this will walk through the full directory structure hierarchy of the source directory. This will return the root directory to return several directories that are part of that directory and the files. So for each of the directories, we're appending to the root path, appending that directory, and we're appending that full path structure to the files to sync list. And we do the same thing for the files itself. We join the path with the root path, with the file path, and that also gets appended to the files to sync list. So the files to sync list contains all the directories that we want to copy, as well as all the files that are present in those directories. Now that we have a list of files to sync, we need to obviously iterate through them to be able to copy them. We're going to be using with the tqdm so that we can have the progress bar. Obviously, the total of items to copy is going to be the length of the files to sync list, so how many files we have to sync. We're going to do a generic description at first, just syncing files, and the unit that shows in the progress bar is of course one file. Every time that we increment the progress bar is by one file. We start iterating through all of the files / directories that are present in the files to list so that is gets iterated of the source path. We construct the destination directory, what we call here the replica directory. So that replica path is going to be the join of the destination directory plus the relative path of the file inside the source directory. So the relative path will allow us to extract the path of the file inside the directory, And with that relative path, we join it with the destination directory. That gives us the full path that should, where the file should be written in the destination directory. Now that we have the full path, we are checking if the file that we are copying can be a directory. So we're checking if it is a directory. If it is a directory and it does not exist in the destination directory, then of course we need to create those directories. Directories can be in a hierarchy. So we're doing that with the OS-McDirs with the replica path that we just constructed before. If it is a file, then of course we also need to additionally check if the file exists or not. And if it exists, if it is actually different or if it has been updated in regards to the source directory. So first we start by checking if the file exists or does not exist in this case in the destination directory/path. If it does exist, then we additionally check using the file comp, the comparison. We check the source path with the replica path, so we're checking the file, if the file is different or not. We're using the shallow equals false, meaning that we're actually checking not just the file metadata, but also the file contents itself. If we would do shallow equals true, then that would only be comparing the file metadata, like the modification time, the size, and all of that. But in this case, we're actually comparing the file content also, or the file signature, if it is different. If it is different or the file does not exist, then we set the progress bar description as that we are processing that file, also a general print description to the terminal, and we copy that file by using the SAAS and the copy, and of course source path, which is the original file, the replica path, the destination path that we constructed. After I finish copying one file or one directory, we updated the progress bar with 1, so that it states that we have finished processing this file. So like I mentioned, optional, we have a flag that we'll see later on once we are passing the command line arguments. We have a flag that states if we should delete the destination directories that are extra. So first we're checking if that flag is active. So if delete, meaning if that flag is active, we need to construct a list of the files to delete. So again, we're getting a list of all the files that are in the destination directory, and it goes in the list files to delete. Same principle as we saw before. We do the whole swap. We append all the directories by joining the path of the root, which is the destination directory root, with the directory that is currently being iterated through. We append that to the files to delete list, and we do the same thing for the files. So this creates a list of all the files and directories that are present in the destination directory. Then again, with the progress bar, similar to as before, the total is the length of the files to delete, description with deleting files, unit file. So we're iterating again with the for loop all the files to delete. This is being stored in this replica path variable. Then we're going to check if the file exists in the source directory. So we're iterating through all the files in the destination directory. We're constructing the source path equivalent of that. So same principle as we saw before, but in the opposite direction. So we are going to join the source directory with the result of the relative path of the destination path and the destination dir. So the file path with the destination dir, relative path of that, we're going to join it with the source directory. So we get the source path, the file that we are checking in the destination directory, and we are checking, of course, if that path exists. The meaning if the path does not exist in the source directory, then that means we can delete it. We're stating the message to the progress bar stating that we are deleting that file or processing that file. The general terminal message saying that we are deleting. Then we have two options. If the path that we are just looking at is a directory, then we're using the SAAS util, and we're removing the tree, meaning removing all the directory hierarchy of this path. If it is a file, we're just doing the OS remove and the file path. And of course, again, we update the progress bar one after we have removed or passed and checked if this file does not need remove. We're just upgrading the progress bar. And finally, we have the main function that is responsible for executing the script and also passing the command line arguments. So we're creating an instance of the argument parser from argparse, so that will allow us to have a parser that is going to parse all the command line parameters. We have one parameter or one argument, which is the source directory, of course, the destination directory, and we have the optional flag, the delete flag, that if it's true, then we delete the destination files that are extra. If not, then we don't delete them. We are passing all those arguments with the parser pass args that comes from all the arguments that we have created. If the args.delete, meaning if the delete flag is present in the arguments, then we're going to print a message saying the extra files are going to be deleted. We then call our check directories helper function with the source directory and destination directory that we have retrieved from the arguments. And if it returns false, as we saw, for instance, if the source directory does not exist, then we're going to exit the execution of the script with error code 1 in this case, meaning it terminated without executing successfully. If all is okay, if the source directory exists, then we're going to call the sync directories function, again passing the source, the destination, and also the delete flag, stating if you want to delete or not. And after all the synchronization is finished, I'm just going to print a general message saying synchronization complete. So let's now see the script in action. And the way that we execute the script is, of course, we call Python. We do the file sync. We pass the source directory. In this case, I have a source directory here that I called sync. And we can create it. We can pass the destination directory. It's called sync copy in this case. And first, I'm going to pass without the delete flag. Of course, we need to add the file extension. So let's see now the script executing. As you can see, I executed our script. So it started by first stating that the destination directory was created. Then it started processing the different files. And as you can see, as it was progressing, the progress bar was updated with first file, second file, third file, fourth file, and finally the last file. These are all small files, so it was quite fast to copy. And at the end, the message synchronization delete. We can see now if I try to run it again. Let's see that it will only print the message syncing files. It did not print the additional message stating that it was copying any of the files because all the files were already present there. And now I can execute the script by passing the delete flag. In this case, since all the files are still present in the source and destination directory, you only get the information with syncing files. But you also see that it executed the delete part because it also ran through the delete files. And in this case, identifying that it did not need to delete any of the files. And that is it. It's a very simple script that can be built to synchronize two directories to create a backup. Like I mentioned, additionally, there's a file sync extended, which let me show you. In terms of additional functionality, it has a dry run. That means you can test without actually affecting the files, without copying or deleting them. You can exclude certain files or the directories, and you can also include the hidden files. You can find the source code for this extended implementation in the link in the description, as also the source code for the basic version, the file sync that we have seen in this video. Like this video if you like this content, subscribe to the channel for more content about Python, Django, and AI. And until next time, happy coding!